My name is Patrick Woodhead, and I'm on the Space Meridian team, and with Miro, who's also at the back there. We've been building out the Spark protocol, as well as the Filecoin Station network. Spark stands for Storage Provider Retrieval Checker, and it's, I suppose, fitting into this framework, it is the protocol behind one of these SLIs, because it's creating data. Oh, here we go. We're ready to go. Yeah, I'll just finish on that point. There was a few points about, like, is Spark just about this one retrieval SLI? Spark, I think, is going to have a few variants, which is going to cover a few different things like time to first byte, stuff like that. But we're also working on something called the Checker network, checker.network, which will be a wider suite of these kind of checking protocols. So that's kind of the development of Spark. All right. I've been working at Protocol Labs in the retrieval market space, and I really believe, my big hypothesis is that in order to find product market fit, Filecoin has to, or a necessary condition for product market fit is that Filecoin needs to have a retrieval guarantee. When we look at these different service classes of, say, like S3, it's all about like how quickly you can retrieve your data. Can you retrieve your data? And so retrieval is such a big part of any storage network. And I think in Filecoin land, we've tended to just think so much about the storage side and the durability side, and really neglect the retrieval side of the network. And I think that's maybe because there's so many hard problems to solve on the storage side anyway, and retrieval obviously comes after storage. You've got to store stuff in order to retrieve it. But we really need to provide a retrieval guarantee to really entice prospective clients to use the network. The second requirement for retrievals is, which I think follows from the first one, is that the guarantee of retrieval must be secured by a trustless and verifiable protocol. So I've heard a few things today from the gentleman over here in particular about how could we just have this kind of guarantee of retrievability done out of band, out of the protocol. And my argument there is that yes, that could work, and we can't stop these things from happening. But if it isn't done in like a trustless and verifiable way, then like what's really the advantage of using this over just some Web 2 offering? Because you're essentially just going into a trusted contract with a provider to provide certain SLAs. So on our team, we believe that we need to try and make this retrieval guarantee secured by a trustless and verifiable protocol. Also, there's been a bit about what L2s can do on top of the Filecoin L1. L2s could offer retrieval or availability guarantees in a more Web 2 style, but they need to be able to rely on the L1's retrieval guarantees, and that, I believe, still has to be trustless and verifiable. And then this third requirement is not quite as strong as the first two, but this is from just working in the space for a few years. I feel like the retrieval protocol shouldn't require the client to pay directly inside the protocol for the retrieval. So that means that when I'm making a retrieval, should I like send some fill across to the provider and then they send back some bytes? We've had a few teams that have looked to that over the last few years, and it's just kind of hit a product market fit dead end, because I don't think people really do want to pay directly when they retrieve. They're so used to just kind of retrieving for free at the time of retrieval and paying in some other means. I wasn't going to go through this slide, but actually I think given the conversation so far, it's actually it's kind of a better thing to go through than the protocol itself. This is to just highlight a few previous efforts in the retrieval space about building a proof of retrieval. So a team called Magmo, they were building these, they were called like Nitro state channels, where you're doing kind of very fast direct payments for retrievals. And here they didn't meet requirement 3, and I think that meant that they just couldn't find that product market fit. People just weren't willing to do those pay directly retrievals. And the same goes for the Mile CDN, which was happening a couple of years ago. The Saturn CDN, which is a project which kind of finished last year and is now morphed into Sriracha, or at least some of the people who are working on it have. Their requirement 2 wasn't met. It wasn't this fully verifiable and trustless protocol. There were centralized parts of it, and also it was became quite gameable. People could just send in sort of any sort of records, and there was an element of fraud. So for that one, requirement 2 on the previous slide wasn't met. And then the final thing to mention is RetrievalBot. This was a retrieval client which is run by sort of the Protocol Labs team, and it was just making retrieval requests and recording the results. And the problem here was that the client of the retrievals was a centralized entity, and so this wouldn't really scale. You couldn't really have this go into being a proof of retrieval because you couldn't rely on the fact that the client wouldn't just tweak the results to benefit, say, certain SPs. That brings us to Spark. This is the new Spark logo. There's been the old logos on the slides earlier, but this is our newfangled one. Spark is trying to target proof of retrievability in a slightly different way from all those previous attempts, and one that satisfies all the three requirements I laid out at the beginning. And I think the really key thing to take away here is that it's not a proof of retrieval for every single retrieval that takes place, because that's when you kind of suffer from these like Sybil attack vectors and self-dealing attack vectors. It's a protocol that builds trust in the ability to retrieve from Filecoin by doing randomly sampled retrievals from randomly chosen deals and then reporting on those results. And we use the station network as a trustless set of retrieval clients to be the agents that start these retrieval requests against the SPs. And so we're looking for this protocol to be kind of end-to-end verifiable without any trusted components. And the components that are trusted at the moment, we're building in a way that anyone could then download the code base and then rerun the code that we're running ourselves at Space Meridian to verify that we've done it correctly and in a deterministic way. I don't know if I'm actually going to go through the Spark protocol now. I think it's like if things are running a bit late, and they might be better to do it in like another meeting with fewer people, because it's going to be going into like quite a lot of detail. So I'm just going to go through all of that, but simply to say, like, we just create the list of all possible retrievals that we want to make from all Fill Plus deals, and then we randomly sample from those. We get the station network to do these checks, submit the measurements, and then we can analyze exactly which measurements they submitted, which ones are valid, and to make sure people aren't kind of trying to shoehorn other measurements into the protocol. And then from that, we can people can consume the Spark data through the API, and it's also published on chain, as people have mentioned today already. And then we also have evaluation and reward logic for the Spark check is running on station for the jobs that they're doing. Yeah, so I think the main thing to mention here, and this kind of draws a distinction between what we've been doing and what Will's team and FIDL and Marta's team's been doing. The output of Spark is this verifiable data set around the retrievability of data from Filecoin. I think there's been some confusion over the year about Spark actually influencing kind of data cap decisions and things like that. It's actually just an input into the work the FIDL's doing and the Filecoin Foundation is doing in terms of how data cap should be allocated. Oh yeah, if you want to see all of these charts, if you just go to dashboard.philspark.com, you can see them all. This is a chart of the overall retrieval success rate of the Filecoin network over the last 6 months. Juan mentioned earlier that it hasn't been linked to incentives. It sort of has, because the data is being used by these teams in terms of how data cap's allocated. So in about April, May time this year, as you can see, the retrieval success rate as measured by Spark of the Filecoin network is about 1%. And then it started being used in these data cap allocation decisions as an input. And you can see that things just started to take off from there. And we've done over a 10x improvement in the Spark retrievability of data on Filecoin, which has been great. Yeah. Thanks. Yeah, just to say that if there's so much to go into there. I know a lot of people got questions about the Spark protocol, like its verifiability, its trustlessness, attack vectors. We've got it all written up in a few documents. Please reach out to me or Miro, who's there in the yellow t-shirt, if you've got any questions, and we're happy to answer it. The whole thing is supposed to be as open and, verifiable in terms of what we tell you as well as possible. So please just ask any questions. Over to Will.
Harsh. And I think we'll hold questions until the combined session. And so I'll talk, and then Marta will talk a little bit more about FIDL one level up in terms of our SLA interaction, and we'll sort of do these together as sort of the nuts and bolts of what is going into this flywheel around SLAs right now. So FIDL, Filecoin Incentive Design Lab, is an entity that spun out a little over 6 months ago, and is taking a bunch of the tooling work that PL previously has been doing around Phil Plus, and is acting as a supporting team to make sure that that keeps happening. And so we're sort of in charge of a bunch of the compliance and sort of tooling around making sure Phil Plus works. In that space, we operate a couple of allocator pathways of our own within Phil Plus. So we give out data cap. We're one of the 50, 60 something team allocator pathways. And we have one for open public data sets. And we have another one to support enterprise clients. We also are operating a faucet for developers, and are sort of using that both as a basis to experiment and make sure that that process works smoothly, and also so that we can set baselines for compliance. So this is talking about what happens with this Spark data and how do we get a flywheel going to incentivize SLAs more generally. We have a couple products or tools that FIDL maintains around tracking compliance and tracking that data cap that's getting used is getting used in the way that it's said it would. One of these is a set of dashboards that you can find off of datacapstats.io. And so from that, you can see from SPs and from the allocation how well we see retrievals happening off of that. So for instance, in our own open data pathway, where one of the things we say is that we're going to give data cap to clients who make their deals with SPs who make that data retrievable, how well are we meeting our own claim that that is what we're doing, right? And so we have many of these allocation pathways that say they're onboarding public open data sets, and that for those data sets to be useful, the thesis of this is useful to Filecoin is that this is going to be data set that then is freely available for users to do computation or other things on. And so if that's the claim of why that is good for Filecoin, then we can track, is it meeting that evaluation? And so that's what these dashboards help do. So these are at a higher level and just give us these things to look at quickly. We also have, each time a client comes to the allocator and asks for data cap, there's a bot that posts a compliance report of what's this client done so far. So, hey, you're giving you gave the first 50 TIBs, you're giving your next 100 TIBs. What happened to that first 50 TIBs? And so we've got a smaller report there that says, okay, it got stored with these SPs, and the retrieval stores for those SPs is so much. And so by starting to post those, we can frame the conversation that happens. I think the thing that's important here is we built this default set of compliance tools, and that is the tooling that a lot of the allocator pathways sort of opted into, because that is cheaper than building their own compliance tooling to show that they're doing well, right? And so there is, like, this is still a broad thing, and we would love to have other allocators develop their own tooling and their own evaluation and demonstrate how they're doing well. But we've got a baseline, which is this set of reports and compliance dashboards that is sort of that baseline stopgap that we're going to use to sort of rise all ships. We've talked a bunch about public and non-public data and where Spark fits in, and I think there's a slightly nuanced picture here. So the 30-second thing here is Filecoin benefits from publicly retrievable data. That's like a thing that is good for the network, right? If you are only giving it back to your company, that is great for your relationship to your customer, but that has much less of a reflection on being good for Filecoin. And so we've got a couple paths to make this work better. One is we can push on our SP stack. We can find magic and get retrieval of the sealed sectors as another option. That'll open another class that we can just have anyone get these sealed data. Or we can have ways to do ACLs or otherwise allow delegation where some subset can be delegated as the entities that are third parties that can neutrally demonstrate that retrieval is possible. And that should cover a large amount of the data. And so that's the basic thing, right? It's not necessarily like always Spark as the one answer, but we do think retrieval at some level in a networked way is going to be a valuable thing for the Filecoin network. And so when that is part of the retrieval story, then we want to make sure we've got a way to validate that SLA. And then the final thing about, what FIDL is doing with tooling is thinking about how to make this process of this flywheel go faster. And so we are working on introducing additional smart contract usage. One of the things that's in the process of landing for allocators that are issuing data cap is that they can begin issuing data cap not directly to a client's wallet, but instead to a smart contract with restrictions. And so, for instance, the data cap can get allocated such that it can only go to the SPs that the client said they wanted, or it can only be allocated when the distribution requirements that have been claimed are actually being met. So you get some leeway, but if you're actually spending it all with one SP, the smart contract stops being a proxy that actually will send those data cap deals. And so we can start to enforce a lot of this rather than having it be this human checking and deciding if it's going to happen. Instead, there's just a smart contract that validates that it actually is happening. And that same thing allows you to say, this data cap only keeps flowing when the Spark retrieval that's on chain is meeting the thresholds that you said you would have for publicly validated data. So a lot of these stop being this thing where there's this person in the loop validating subjective multiple things that are just sort of a race to the bottom, and instead just become a thing that has to happen if the deals continue to flow. So that's the hope at making this a little bit smoother. So that's a sort of technical view into the slice of stuff around Spark. And now I'm going to hand it over to MPG to talk more broadly about how FIDL sees SLAs.